Good evening, everyone. Am I audible to you all? Please confirm in your chat box. Yes, very good evening to everyone. So, how was your paper? CSIR question paper, how was it? Tell me, everyone. Did you did you find it tough? Did you feel that the CSIR pattern has changed? Do you feel the questions that you studied were the topics which you studied, there were no questions from it? Yes. So, whatever it is, you should not worry because we are here to explain all the concepts which are related with this particular topic, Unit 1. Today, I have come to discuss the concepts about Unit 1, which is molecules and their interaction relevant to biology, which is nothing but biochemistry topic, isn't it? All right. So let's begin with the first question. Now, this is from morning batch. First, we'll discuss the part B questions of morning batch, and then the part B questions of evening batch, and then we'll go to the part C questions of again morning and evening batch both. Okay. Yes, Graham, that's right. The pattern has indeed changed, but actually, the pattern of questions I will not say has changed. Just that they have twisted the language a little bit. Okay, and some topics which are not expected generally they don't come. For example, this first question that is on your screen regarding Ramachandran plot, it's been a while since this question was asked. Okay, so the topic from Ramachandran plot since it was asked, but this time yes, there were two questions on it. Let me discuss. I'll tell you as I go forward, I'll tell you regarding the analysis and everything. So, given below are Ramachandran plot for four different proteins, choose the correct pair of proteins, both of which are predominantly alpha helical in nature. Okay, so we have this A, B, C, D. They have given four plots over here. Okay, now as we know in Ramachandran plot, we have total four quadrants, right? If I show you the diagram for here, so here we have four quadrants in Ramachandran plot. In the y-axis, we take the Chi angle, dihedral angle, and in the x-axis, we take phi angle, which is the angle between the NC alpha. Okay, if you are aware of these dihedral angles. So generally, the standard Ramachandran plot. This is what is the standard plot in this alpha helix. We get two type of alpha helix. One is the left handed, which is not so common with L amino acids, but with the right handed helix it's quite common, and that we have in the lower left quadrant. Okay, four quadrants are there, the centers are the zero, and since these are talking about angles, we have minus 180 to plus 180. Same here also, minus 180 to plus 180. So alpha helix falls in this region where we have both the phi and chi in negative values. Okay. So that's what, when torsional angles are plotted in a Ramachandran plot, a restricted area on the plot is obtained, which can be used to identify and check the secondary structure in a given polypeptide. So backbone torsion angle for right-handed alpha helix are phi is 57 degree and chi is 47 degree, minus 47 degree, minus 57. So therefore it occupies small area lower left quadrant. Okay, whereas this quadrant where we have the phi as negative and chi as positive, here we have the collagen triple helix, beta strands and everything. And that's why here, if we have the beta sheet, so you will see more dot density in this quadrant. Now this question was tricky. Why? First of all, the question is asking for proteins which are containing predominantly alpha helix, so you have to focus on this part, right? In this one, yeah, good evening, Sneha. So we will discuss both. First we'll discuss part B, questions of morning batch, then part B question of evening batch, then again part C of morning and part C of evening. Okay. So what I had over here, what why the question was tricky is predominantly alpha helix. Okay. So here in A, if you see, they have beta sheets also. See, dot density, if it is more, it means it is a repetitive structure, right? So alpha helix and beta sheet, these are repetitive structure. So you should look at where these dot densities are more for alpha helix. Okay, here it is for beta sheet. So you should not select A. That's why, because here beta sheets is more, alpha helix is less. But here if you see, you have only the dot density in the lower left quadrant in C, which means that this has alpha helix. Okay. Even in this one also, in D also, you will see that you have such dot density in lower left quadrant, which means here also it would be alpha helix. Whereas in A and B, if you see, the dot densities are more in for beta sheet, but you have to select predominantly alpha helix. So such is the trickiness of CSIR question papers, questions, that even a single word can make a difference. So, since the question is asking for proteins containing predominantly alpha helix, hence we should check the plots with more dot density in the lower left quadrant and less dot density in the upper left quadrant. So, that we observe in uh, protein C and D. Yes? How many of you got it correct? Or how many of you missed out the word predominant? Yes. So, let's go on to the next question. So, which of the following pair correctly matches the enzyme with its allosteric activators? Now, this is a metabolism based question now. So, we have metabolism of only the carbohydrates, which is asked over here, but it has asked three reaction concepts, means three reaction pathways concepts. One is glycolysis, another one is gluconeogenesis, okay, and another one is your that pyruvate dehydrogenase, that is PDH complex. So three together they have asked. Generally they will ask for one, only one of the pathway regulation, but here they have asked for all three. Okay, Graham got the previous question correct, very good. Okay, so here, if you look at so here is also correct answer. Yes, very good, Anuj. Your answer is right. Its correct answer is option 4. So you have to select which is correctly match. Okay, so yes, for pyruvate kinase, it's the last enzyme of glycolysis. The activator is indeed fructose 1,6 bisphosphate. So here you have to focus on the word activator. Okay, just don't focus on allosteric, or if simply it is involved in regulation. Specifically it has to be activator. Okay, because of which the second statement becomes false. Okay, fructose 2,6 bisphosphate, it is mentioned it is an allosteric activator of PFK1, but the question is asking of citrate and acetyl CoA. Citrate and acetyl CoA, it is involved, definitely it is involved in, sorry, option 1 is incorrect, because it is mentioned that for phosphofructokinase PFK1, citrate is an activator, but it's not. Citrate is actually an inhibitor, it inhibits PFK1. Okay, if we had to talk about activator for PFK1, it should have been fructose 2,6 bisphosphate, right? So that's why the first option is incorrect. And then the third option, second option, it is talking about the pyruvate dehydrogenase. So if you see, pyruvate dehydrogenase is the active pyruvate dehydrogenase, and this is how it is becoming inactivated by phosphorylation. Okay, so again this part was tricky, because generally what we have studied is that acetyl CoA and NADH, they are positive activators of kinase enzyme. Okay, that is the PDH kinase. Okay, so this time the part B questions were also like kind of tricky in a very subtle sense. It was not obviously tricky like how part C questions are, but subtly they were prone to making mistakes. Okay, so here you have the PDH kinase, which was activated by ATP acetyl CoA NADH and inhibited by pyruvate. Okay, but it is not asking about PDH kinase, it is about asking about pyruvate dehydrogenase. So what is the role of PDH kinase? PDH kinase will inhibit PDH, inactivate PDH by adding a phosphate group. Okay, so that is why if this needs to happen, if it is inhibiting, okay, then these are acting as catalysts for inhibition. They are helping in inhibition. Indirectly, they are helping in inhibition. So that's why the end products of the overall reaction are potent allosteric inhibitors, not activators. That is why even option 2 is not correct. Okay. Then the third option says pyruvate carboxylase. So pyruvate carboxylase is an enzyme in the gluconeogenic pathway. So this is activated by Mg2 plus and also through mass action by an increase in the ATP and ATP on ADP, the action of it. Okay, means ratio, which means that ATP should be more and ADP should be less. That means if ATP is more, the reaction will be activated, so that's what is mentioned. But if ADP is less, then it will be inhibiting it. Okay. So it means if ADP is more, then it will inhibit. If ADP is more means ATP is, if ADP is less means ATP is more. So in that case, it will be activated. So that's why even option 3 is not correctly matched. Okay. All right. So moving on to the next question. This is regarding again Ramachandran plot. So in the representation of the dipeptide which is shown below, the superscript -1. So here we have carbon -1 and we have, that is N, which is +1. That means this is the previous residue and this is the next residue. Okay, that's what they have mentioned. Now the atomic coordinates of how many atoms and which of the atoms are required to uniquely define the torsion angles phi and psi of the Ramachandran plot. Okay, so they are asking that these angles, we know that this is the CC alpha, this is what is the psi angle, and NC alpha, this is what is the phi angle. So they are asking that this particular dihedral angle is influenced by how many atoms and which all atoms. So atom names they have given, like C alpha, C, then N plus 1, C minus 1, this N. So again C. So these all atom names they have given. You have to select that which all angles are influencing it. Okay, so this is psi and this is phi. You might think that this one angle is influenced by these two atom positions, but it's actually not. A dihedral angle is like the entire geometry. So whatever is linked with it, the entire thing. So these four atoms will be involved for psi. Not only this, but also the positioning of these atoms. Okay. So if you see here, this is how dihedral angles are important. You can imagine a chair which is positioned towards the side. Imagine a chair. Okay. So how will the coordinates of the chair look? The top of the chair, then the bottom and the middle part. This is the seat actually. So two corners of the seat. Okay, and then the legs. Okay. Now imagine you turn the chair towards yourself. Okay. So if you turn the chair towards yourself, then this seat, these two corners, it will be looking like a line to you, means it will be the same, isn't it? So this is how the angles rotate. It can rotate like this 180 degree, right? So that's why the coordinates will be affecting for four atoms. The torsion angle, dihedral angle, is defined by three consecutive bonds involving four atoms. The angle describes the rotation of the chain around the middle bond. To uniquely define the torsion angle on a Ramachandran plot, atomic coordinates of four atoms are required. So phi angle is defined by, so if I show you, one is the C alpha. C alpha means of the preceding residue. Yeah. So here we have the C alpha, which is given by C minus 1, and then we have N, then we have C alpha, then C dash. C dash is nothing but, so C dash is nothing but this C. Okay, so it is given by the C minus 1, this one, that is previous residue, then N, then C alpha, and then C. So all of this will affect the phi residue, which is phi angle, which is the NC alpha. Okay, and this psi will be affected by, now you can easily say, one is the N, then another one is C alpha, then you have the C dashed. Okay, and you have the N of the next residue. So as you can see here, for psi angle it is N, C alpha, C dashed. and the n of the next residue. So these four atoms provide the necessary coordinates for calculating torsion angles. That is why the option will be correct answer will be option 1. Yes, everyone got this correct, right? Can we move on to the next one then? So next is part B question again, that is 24. This is regarding water molecule structure. So this was extremely easy question. The oxygen atom in water is in sp3 hybridization with an angle of this. So they have asked about the hybridization and also about the water angle between the HOH bond. So which of the following statements regarding the structure of water molecule is correct? Okay. So as you can see here, option 3 is applicable here, which is you have the sp3 hybridization and the angle will be 104.5. Okay, so here the hybridization of the molecular orbital in water is sp3, which means that a water molecule has tetrahedral structure even though the three atoms are coplanar. What actually happens is the lone pair of electrons. So oxygen has two lone pair of electrons, so they would want to push each other so that they can position themselves quite away from each other. Okay, that's why the angle between them becomes 104.5 degree. It takes a bent geometry. All right. And talking about the overlap, so we have the mixing of orbitals in water regarding the oxygen and also the hydrogen. So as we know, this would be the hydrogen. This is the isolated oxygen atom in which you have the 2s orbital and the 2p orbital. But when we have the hybridization with water, then it becomes a sp3, so in which these would be lone pairs and this would be the bonding electrons. Okay, just because you can see here one hydrogen, they will overlap, isn't it? There would be one s in hydrogen also, you have one electron, so though they will overlap with that. So that's how these would be forming the bonding pairs and this would be the lone pairs. Okay, so correct answer is option 3. So I would like to inform you about one offer that we have today. That is for the upcoming Josh batch for CSIR NET December 2024 and also for December or for June 2025 exam. Okay. So what do we? This is exclusively now for this batch which is running. So you should hurry up if you want to enroll because we have very limited time for this offer. We have a 78% off on this coaching of Josh batch. So the link would be already there in your chat option. And in case you want to enroll, then you have to call on our toll free number, which is given here. And also, our office number is there. You can call there as well. Or else, you can just visit our Biotechnica stores.biotechnica.org. And from there itself, you can select this coaching. Okay, so what I'll suggest is that you have to go to the site, and if you want to avail this offer, you have to use the coupon code freedom. Okay, you have to use the coupon code freedom, and link is already given to this. There is a 78% off on this coaching, and offer is valid only for today. Okay, so this offer is only valid for today. In case you want to enroll, then you will have to hurry up because we have limited seats and we have limited time also for this offer. Okay, all right, moving on. Now next is the part B question of evening session. Yes, so compared to morning session, I think evening session was comparatively slight easier because morning batch questions were almost coming up to the level of part C for one or two questions. So let's check the part B questions of morning batch of evening batch. So this is regarding pH. pH of water in Lonar Lake was found to be 10.5, 10.3. So they have given all the pH values. Okay, and yeah, and this also for measurements taken once daily over 6 days. So what would be the average pH of the lake water during this period? This is what the question is all about. So yes, you have to tell me how to go forward with this question. Tell me how to calculate the pH, average pH. Yes, anyone? What have you done in this part? Calculating the average pH part. What have you done here? How many of you have taken average of all of these? Okay, so it doesn't work that way. So what you have to do is, no, it doesn't work that way. You can't take the average of the pH values. Okay, what you have to do is, first you have to calculate for the hydrogen and concentration. Okay, pH plus POH is 14, but you have a lot of pH given, no? So how are these going to work? Isn't it? See. So that's why this question was tricky, even part B question, but still it is tricky. So we know that the pH is minus log of H plus ion concentration, isn't it? We know this value. So what you have to do is, first we can say that H plus, if we take H plus, um, minus log will come over here. Okay, so that means H plus is anti-log of minus pH. Minus will come this side and then anti-log will come this side. So for each of the pH which is given, you have to calculate the H plus. Believe it or not, it makes a difference in your answer. You cannot directly calculate the pH because pH is a logarithmic number. Okay. What happens is, you think about it. If you take H plus and concentration as 10 to the power minus 7, then pH will come to pH 7. But if you take 10 to the power minus 6, that is almost 10 times, that is 10 times you are decreasing the hydrogen, you're increasing the hydrogen and concentration 10 times, but still the pH value, it will increase only, it will decrease only 1 unit. They are inversely related, pH and H plus. So if you increase the H plus ion 10 times, then your pH value is decreasing by only 1 unit. So when you have this pH values, why the average will not work is because of this. Here there are lot of changes in the hydrogen and concentration. So just by taking a pH number, taking average is not giving you the accurate hydrogen and concentration. So separately you have to take H plus and concentration for all of them. Okay, so if you just calculate, like if you have to put pH 10.5, so anti-log of minus 10.5, I believe they provide you a calculator, online calculator. So with that you can easily calculate. This is not such any heavy calculation. Just put in anti-log of minus this minus 10.5 and you will get this value. Okay, so these are the hydrogen and concentration of all the days. Okay, now you have to do average hydrogen and concentration. Now you can take the average, okay, of all of them. So since there are total 6 hydrogen and concentrations, divided by 6 you have to do, you have to add all of them and divide it by 6. So first you add up and then you can divide by 6, so it will be coming to this part. Then you just have to take the pH of it minus log of this and you will get 10.36 as answer. But if you would have taken the average value of it, I think somewhere you were getting something like this or something. So if you can see the answers also, there is very fine difference between them, 2, 3, 4 and 6. Okay, just 0.10 difference it is there. And yes, the hydrogen concentration, since the pH values are very close to each other, so hydrogen concentrations are not that different, but yes, there is a small difference. I hope you are getting it. Why taking average of pH will not work for this question. Okay, so this is what happens when you're very close. Yes, yes, Neha. This is what happens when you have a superficial preparation and when you have an in-depth concept. Okay, so don't learn for the sake of just memorizing the concepts. You have to understand the relationship also. One small thing such as this, a formula, can be looked at in many different angles. And as CSIR aspirants, you have to look at all the angles and keep thinking and relating about them whenever you study anything related to them. So one is that they're inversely proportional. Okay. Second is that they're logarithmic value. Okay. So a small change in this can lead to a bigger change in the other one. So these things, yes, at Biotechnica we teachers definitely focus and try to incorporate these concepts in the students. Okay, so that's what I said. In case you are preparing for CSIR, do not delay. because these things you will not get by yourself. And masters, even if you're good in your masters, you had good ranking, but it doesn't help you much in CSIR because syllabus is very vast. It's many things are not covered in masters, which is there in CSIR. And the level also masters is very superficial. Okay, and even whatever you feel that okay, some other sources you are studying, some notes, ready-made notes, or any videos which are available, they are they are doing a negative effect on you probably. Okay, so select the right source of your knowledge. Be it reference books, but reference standard reference books will take a lot of time for you to imbibe the concepts. Okay, so better take help from the experts who are having years and years of experience in churning out successful candidates from these competitive exams. Okay, let's go to the second question of part B. This is regarding stereoisomers, right? So carbohydrates, which of the following statements regarding the stereoisomers of D-glucose is incorrect? Well, here we need to know that since D-glucose, it will have four chiral carbons, isn't it? Glucose has four chiral carbon, and you have the uh, formula, Van Hoff's formula to calculate stereoisomers, 2 to the power n. Total 16 stereoisomers will be there, right? So 16, out of that there are several names for them. First of all, out of these 8 will be D isomers, and 8 will be L isomers. So these would be mirror images. Okay, this and this, they would be mirror images of each other. So first you have to know the isomers, and then you can find out which is of what. For this, I will not say again it was an easy question because generally people will not remember the structure of the isomers. Okay, but yes, what most people might know is that mannose and glucose, they are isomers which differ in their configuration around only one carbon, that is a second carbon. Okay, so these are what are called as epimers. Anyways, this question is about epimers only, so that is fine. Epimers are diastereomers which differ only in one stereoisomer out of two or more. They are called as epimers. Okay, so epimers, we know that glucose and mannose are epimers at C2, and we also know that glucose and galactose, they are isomers at C4. That is epimers at C4. So from there you can select, but the problem is it's not about one correct. It is about many correct and one incorrect. So knowing that is not enough. Yes, D mannose is in fact a C2 epimer, so this is correct. D glucose is also a C4 epimer, even this is correct. Now, between these two, you had to know it. So, generally, people will not remember about allose and talose. So, that's what was a little bit tricky, I felt. Okay, so they still have given about that. Now, if you look at the glucose and talose, but here you can use a little option about that. Here they are different, and here also they are different with galactose. So that way you can figure out, you are left with this C2 carbon and you are left with the C3 carbon, isn't it? So anyways, the C5, sorry, the second one, it is different with the with mannose, yes, and the fourth one is different with galactose. So you are left with C3 and you are left with C5. Okay, so C3 and C5, any one of them you're left with. So C3 is the at the epimer for C3 of glucose is allose, and for C5 it is C for C5 it is not talose because C D idose is a C5 epimer. So the third statement, the second statement is correct. Allose is a C3 epimer, but for C5 it is not talose, rather it is idose, which is differing with that of C5. Okay, so D-talose differs from D-glucose at C2 as well as C4. So that is why they are not epimers. Okay, if you look at talose and glucose, they differ at C2 also and C4 also. All right. Now, next question in evening session of part B is, which one of the following properties of grooves is a hallmark of the Z form of DNA? All right. So, yes, I think some of you can try this. We had discussed in our classes, biotechnica classes. Yes, anyone wants to try this? what type of what type of grooves do we have here? Okay, Sneha says option 1. Anyone else? Come on, students, give me your answer. What is the difference between all this? ABZ DNA, what is the difference between them? Okay, so most of you are saying option, yeah. So most of you are saying option 3 and 1, but actually, Kirti, your answer is right. Okay. See the difference. There is a lot of difference between the ABZ form DNA, AB and Z forms of DNA. This is not what is a very unknown topic, I will say. This is quite a known topic. Okay. So here we have the A DNA and B DNA. They have major and minor grooves. They differ in their depth and also the structural surface. But if you know about ZDNA, ZDNA doesn't have any major groove. The reason is because ZDNA mostly is taken by a sequence with alternating CG bases. Alternating CG like this, it will be there. And that to this CG, they are in alternating glycosidic conformations. So you would be knowing about syn and anti, right? So first of all, you have this ABZ DNA. So in ZDNA, the purines are rotated into the syn conformation. So as I said, the CG, the Gs are in syn glycosidic conformation, whereas the C's, they are in anti conformation, right? So how exactly it looks, if this is the phosphate and um, this is the ribose sugar, so this is what a syn conformation looks like, okay, which is towards the phosphate backbone. This is what is the base, okay, this is the phosphate, this is the sugar, and this is what is the base. Whereas an anti conformation, it looks like this, it is away from the phosphate backbone. Okay, that is what an anti conformation looks like. So if I have to draw one syn conformation, okay, and then the next one will be an anti conformation, then again one will be syn conformation, then again one will be anti conformation. And this is just for one strand. You have another strand also. Now here, from here you have one anti conformation, and then you have one syn conformation, then again you have anti conformation, and again you have syn conformation. So you can see the bases, the base pairs, they are going in zigzag. Okay, so that's why the ZDNA word comes. ZDNA stands for zigzag pattern, and that's why what happens is the folding, when the, see why grooves come. You have to imagine a ladder, and then you're twisting the ladder, right? So you're twisting the ladder. So you will be getting a spiral shape, isn't it? So you'll be getting a spiral shape like this. So this is the groove what is created. Because these zigzag pattern, the backbone is not straight in ZDNA. The backbone of the ZDNA is actually a ladder, it looks like this. So when you twist this ladder, there is hardly any groove left. So this is how ZDNA looks like. Okay, the entire the part which is like having more opening towards the surface, instead of going like a groove like this, it is protruded towards the surface, it is protruded out. Okay, that's why here you don't have any groove. Major groove in BDNA is deep and wide, whereas in ADNA it is deep and narrow. Okay, these are made up of polynucleotides with two repeating units, unlike one in A and B DNA, hence forming a zigzag pattern coil. Okay, I hope that is clear for everyone. So, our correct answer is option 4. So, yes, come on. Now, you have to answer this also. Let's go one by one. Yes, I want answers from every one of you. What have you answers regarding the metabolism part, transamination, amino acid catabolism? Have you people studied about it? Yes, you people have to answer. Come on. Then we will go for our next topic, next concept. Okay. So most of you are saying alpha ketoglutarate, aspargine. Yeah, yeah. So most of you are right. Very good, everyone. So answer is in fact alpha ketoglutarate. Okay. So it's asking. It's a very easy question actually. Which of the following compounds can be a direct acceptor of an additional amino group derived from amino acid catabolism? Right. So we have the transamination reaction. If you would know, we know that generally we have the carbohydrates as the energy source for molecules, but we can also have the like amino acids and lipids which can also contribute to the energy when there is not enough carbohydrate sources. Okay, so that's where we have this aspartate, which is an amino acid. Okay, and we have the oxaloacetate, right? So aspartate, it can alpha ketoglutarate is also a keto acid, we know that from carbohydrate. So this can directly accept the amino group. Okay, alpha ketoglutarate can directly accept the amino group because we want aspartate to convert into a keto acid. Okay, so that's what happens. Aspartate, after giving of the amino group, as you can see, it has given that amino group to alpha ketoglutarate, because of which it has converted into an amino acid. So which is fine because we want to get a keto acid so that we can get energy out of it, isn't it? So this reaction is very important reaction, and the enzyme for this is aspartate transaminase aminotransferase, and the cofactor for this enzyme, generally in transamination reactions, PLP, pyridoxal phosphate, it is a coenzyme for it. So that's why we get the keto sugar which can enter into the carbohydrate metabolism pathway. Okay, so this is a very key compound because it is accepting the amino group directly from an amino acid, and it is very crucial for the deamination, because if amino group is there, it cannot enter, amino acids cannot be broken down for energy, they cannot enter the carbohydrate metabolism pathway. So that leads to the formation of glutamate. Okay, so yes, very good everyone, you have done correctly option 3. Okay, the next question. Yes, quickly we'll finish off this part B questions. Yes, I want correct answers from everyone. Okay, many of you are saying option 3. Keep it going. I want everyone. Come on. participate so that you will be you will remember. If you're getting it wrong, it's fine. Anyways, I'll be discussing with you just to know what you people have answered it regarding. Proton motive force is a very common topic from this carbohydrate metabolism, oxidative phosphorylation. It is important in both NET exam and GATE exam. So you should be getting it correctly. You must have studied it properly, I believe, right? So what is proton motive force? What is proton motive force and when do you get it? Regarding oxidative phosphorylation, which are the contributors, why it generates? So the main reason for proton motive force is what? It's the energy, isn't it's the electrons, isn't it? The electrons are transported, and that is why the protons are able to get transferred to the other side, isn't it? Through the proton pumps. So this is what you have to answer, right? Yes. 1 minute. Yeah. So we have here, you can see the mitochondria. It's a double membrane structure. We have the outer membrane and we have the inner membrane. Now, in inner membrane, we have the electron transport chain. As and when the electrons are transported, the protons are pumped to the other side, that is towards the intermembrane space, right? And from there, they want to come back to the matrix, isn't it? So that force which is created in the intermembrane space, from that, once they come out to the matrix, means come inside once again, they will be able to convert ADP into PI, ADP and PI into ATP. Okay. So it is used for ATP synthesis, proton motive force, and transport of ions and molecules across the mitochondrial membrane. The options involving ATP, ADP, and phosphate ion transport. They will directly rely on PMF, because once ATP is produced, ATP has to go outside. Okay. And when ADP and PI is required inside the matrix, these are the raw materials, they have to come inside the mitochondria. Okay. And ATP has whatever is synthesized, it will go outside the mitochondria. So how much PMF is there, depending on that, it will be decided how much ATP synthesis will be happening, and based on that, it will be decided how much ADP or ATP will be released or required, right? But NADH, now what is NADH? It's the source of electrons. Okay, NADH, from the glycolysis or from the TCA cycle, they would give the electrons to the electron transport chain. The transport of NADH from the cytosol into the mitochondrial matrix does not directly use the proton motive force. It involves shuttles like malate aspartate. Okay, it doesn't, even if proton motive force it is not there, even if the protons have not accumulated, or if it is still there, proton motive, the H plus ions have accumulated, it will not depend on NADH, will not depend on that, or the proton motive force will not depend on NADH, because NADH is just giving away the electrons to this complex one of electron transport chain. Okay, so it is written that it is proton motive force is not used for what? So yes, it will rely on the transport of ATP, ADP, and also the phosphate ion, but not for transport of NADH. Yes. So correct answer is option 4. I think Sanjana gave it correctly. Yes. So where did you go wrong? Tell me. Yes. I hope I am able to clarify your concepts over here, isn't it? Right. So miracles start to happen when you give as much energy to your dreams as you do to your fears. You cannot just wait and some miracle will happen, that I'll get the concepts and somehow I'll be clearing. No, you have to put a lot of effort, you have to give a lot of energy. Yes, you want to be there in your dream institute, but just like that, it will not happen, right? You want to be a doctorate, you want to be a researcher, and that is so much prestigious. But just like that will not happen. You have to overcome your fears. Yes, you're scared of CSIR party questions. Practice more questions. That's the only option. You have to face your fear. Okay, so what you can do is practice questions. We have biotechnicas question series, mnet series, toughnet series, as much and as questions you want, we are there to provide questions to you, but you have to avail it. Okay, so the more questions you practice, the better you will get it. Now let's jump to our scariest thing, that is the part C questions. We'll start with the morning session. This is the first question in morning session regarding the protein folds. Yes. So we are entering part C. We can expect some complexity. Tell me, what all you people answered? Let me see. Regarding this part C question, what all you people have answered? Morning batch. Yes. How many of you had morning session? Come on, you people. Or else, even if you are evening batch, so you're getting to know the questions. No, it's good that some questions you already know and some you don't. So tell me, out of this, which options will be correct? Or at least what have you people answered? Which out of these have you people answered? So regarding protein folds, um, definitely you have to apply some concept of protein fold, but here you don't have to apply anything with your obviously what knowledge you have. Okay, so rather you have to analyze the structures properly. Okay, what structures they have given, you have to just analyze them. That's all you have to do over here. All right, so let's have a look how to solve this question. Okay, most of you have given two, as I'm seeing, two, four. All right. See here, um, the topology. If you see A and C, okay, you start with N over here. You start with N, then you go towards like this. You go like this. Then you have going towards the last one. You're going towards the last beta strand. Okay, then again the arrowhead like this, arrowhead like this. Then you go to the next one. So next one, you go like this. Then again arrowhead towards this one, arrowhead towards this one. Then again this one and the arrowhead towards C. Arrowhead towards C. If you see, this is just reverse of it. Okay, so you have to see like all four are of different fold, or four are of same fold, or ACD are of same fold, A and C are of same fold. So obviously the answer is pretty much clear over here, that A and C, they are depicting similar beta sheet arrangements where the strands are connected in this way that forms the same topology. Okay, the N terminal and the C terminal are on the opposite sides, right? And the beta strands follow the same pattern, though it is just reverse. But if you check diagram D, okay, it shows a different fold. Why? I'll tell you. See where the N terminal is lying in A and C, okay, how they are lying. So the interaction of the strands or connectivity pattern is different. So yes, N and C, they are lying close to each other, here also close to each other, but the pattern with which they are connected, here N and C, they are next to each other, placed next to each other, but they are not interacting. Okay, means they are not like the, obviously they will have more position in them. You can see that from this arrow it is going, and here from the like opposite of the arrow it is going, but here it is the other way around. If you see the C terminal, the N terminal is going like this. Okay, and then instead of like coming back like this, it is having an it's like you have to observe it. right? It's a different fold because the connectivity pattern is different. I'll tell you, for example, N terminal, which is containing the strand, it is in periphery, okay, and that too it is in between A and C, isn't it? So here you can see the N is in between these two strands, correct? Here N is outside, but here it is in between the strands. Obviously, when beta strands are next to each other, there will be interaction, and that is a very important criteria for a fold to form, that the strands will be interacting with each other, okay? So that's why even if it looks same, but they are not same because the positioning of the beta strand is different. Fine. And diagram B also has a different fold that it shows a different connectivity altogether. Fine, because here we have a strand between this last first and strand going like this, but in all of them it is just small beta turns. So here we have a big turn which is there, but here we have small turns. So that is why these and these are completely different. Is it clear or not? Was I able to make it clear to you people? Yep, exactly, Graham. A and C are just inverted. All of you are right. So, Graham and Kirti got it correct. I hope it is clear for everyone else. Okay. Okay, now is another numerical question. So, what formula you will use over here? Tell me. What logic? All of you have to give me one logic that you feel is important over here. What logic will you be using regarding this question? And why this logic will be applicable? So this is a paired reaction, isn't it? Coupled reaction, what we say, that these two reactions they will happen together. So what do we do in such kind of cases? Anyone attempted this question? We are still in the morning batch part C questions. Come on, quickly tell me anything you would like to tell me here, because if it goes in one direction it will not be interesting. Let's make it two-way interaction. No one has attended this question. Okay, at least can you tell me what is the formula that you will use here? There's a relationship. What formula you're using here? Okay. So, anyways, I'll tell you how to solve this question here. See, for coupled reaction, equilibrium constant, no problem, Graham. Equilibrium constant K equilibrium for equation 1 and 2 are given. So the only thing that we used to that we need over here is the delta G is equal to minus RT ln KQ. So this is a very straightforward question, right? The only logic that you need to apply over here is you have to first calculate the delta G individually for both of them. You see this state functions, that is delta G, then entropy, then enthalpy, and even the electron, this reduction potential what we have, E0 dash. So all these are additive numbers. Okay, additive numbers means you have to, if you're taking for a reaction, you have to get the net value, you have to add all of them up with their signs. Okay, with their positive and negative signs you have to add them up. So that's why the only logic is separately calculate delta G for both of them using this formula. Ln is nothing but 2.303 log. Till date, always CSIR has given questions from this thermodynamics topics, numerical questions. They have given only with this one formula. You don't have to apply. Don't have to know a lot of formulas. You just have to apply this one. Okay. All right. Let's see, Lokesh, what would be the correct answer. So for the first reaction, they have already given it is 270 keq, and for the second one it is given 890. Accordingly, you have to calculate. Okay, so for reaction 1, standard free energy change, anyways, this is what is the formula. So for reaction 1, R value we will take 8.315, because they have given in kilojoule per mole. The options, if you check, they have given in kilojoule per mole. So that's why we would be taking kilojoule, means the R also we have to take it in joules only. If it was given in calorie, we would have taken R value according to calorie. And temperature, they have given 25 degrees centigrade, but for always thermodynamic calculation, we have to add 273 to it to make it into Kelvin. Okay, so that's why here we have temperature 25 plus 273, 298. Temperature, R is 8.315. So for first reaction, KEQ value is 270. You just have to put all this in formula, R value, and then temperature, it is 298. And since I said ln is 2.303 into log, so 2.3 into log of 270. If you properly solve it, you have to be very careful in solving such kind of questions. Before putting into formula, you have to see everything is in same unit. Okay, so kilojoule per mole and everything, and temperature is in Kelvin. So similarly, same thing you have to calculate for reaction 2, but instead of keq value of 270 in reaction 1, you have to put 890. Now this, if you calculate, you will get this much joule per mole. See, R value you take in joule per mole. Okay, that's why R value formula unit also you should know, but you have to convert into kilojoule, because the answer is given in kilojoule for both of them. All right, so since these are coupled reaction, net G0 dash will be delta G01 plus delta G02. So together, if you add them up, then this is what you're getting. Now, what did I say? You have to add it with this sign. So minus the first delta G01 plus minus of the delta G02. So basically, you have to add them up. That is this minus this. It is adding up, and that's why you will have minus 30.7 kilojoule per mole. So that is coming somewhere near option 3. Yes. Everyone got it? So where did you make a mistake, Lokesh? Tell me. Where did you make a mistake? All right, let's move on to the next question while Lokesh tells me something regarding his mistake. Yes, anyone wants to say anything about this question? It's about enzyme kinetics. Which of the following options about the rate of reaction at very low substrate concentration is correct? So how have you approached this particular question? Tell me. Anyone attended this question? No one? So what is the rate? You people know about the rate, right? Rate of reaction, how do you define it? Here, do you have to use the Michaelis-Menten kinetics or not? First tell me that. Do you think you have to use your Michaelis-Menten kinetics, yes or no? Okay. So option 2, Somen is saying, let's see, have a look. See here, given the information that the Km for propionate is half of acetate. Okay, Km is given, so correct answer can only be determined by using the Michaelis-Menten equation. Okay, particularly at very low substrate concentration where substrate is much less than Km. We want to find out the rate through this Michaelis-Menten equation. We know Michaelis-Menten equation is V0 is equal to Vmax into S divided by Km plus S. Okay, now when you take at very low substrate concentration, we know the substrate concentration is much less than the Km value. Okay, Km is what? How do you define Km? It is the substrate required to reach half of Vmax, isn't it? So obviously for reaching half of Vmax you need quite a lot of substrate. that quite a lot of km, isn't it? But if you take at a low substrate concentration, then that much substrate is not there, that the reaction will reach half. So at that time, what you can do is, for this denominator, which is km plus s, you can almost ignore the substrate concentration. Okay, because let's say km is around, I'm giving an example, 10 for example, and substrate is much less than that. So let's say I'll take zero point 0.1. Let's let the substrate concentration be zero point 0.1 millimolar or something, and let the km be 10 millimolar. So the total of the denominator in that case would be 10 plus 0.1, which will not be much different from 10. So what you can do is you can ignore this part. Okay, at very low substrate concentration, the equation will simplify to v is the rate, okay, and v max is the maximum capacity, maximum velocity, into s, you keep the numerator as it is but divided by just km. Now what it is said, that km is half of that of the acetate. Propionate km is half of acetate, which means you can easily bring a formula for this, that km of propionate is equal to km acetate by 2, because you have the means one half of acetate. Propionate is one half of acetate, so propionate is equal to one half of acetate, km obviously. Okay, now you got the km values, but before that you can find out the rate of propionate utilization. So the rate v is equal to v max into s, what we had calculated, divided by, for propionate you want to calculate, means you can put this, because anyways it is km, that is what we had got the formula over here, isn't it? So instead of km of propionate, you can write km of acetate divided by 2. This is what you can write. Okay, so if you simplify this entire thing, the rate v, you will get v max into s into 2 divided by km plus acetate. So basically for propionate, you will be getting V max into S into 2, okay, into 2 divided by km of acetate. Okay, now same thing you have to calculate rate V of acetate utilization. Okay, so acetate utilization will be same way. If you do it, instead of writing like S, means you will not write plus S, just write the km value. So for rate of for acetate will be, this is for propionate and this is for acetate, it will be V max into S, okay, divided by km acetate. Okay, so as you can see here, V max get cancelled, right? Km acetate gets cancelled, right? Even SS gets cancelled. So that's it. You have your ratio, right? So everything gets cancelled. You just have the rate of propionate, which is 2 times, means the V propionate divided by V acetate means 2, which means the propionate is 2 times that of the acetate. Okay, that's why the answer comes to option 2. So as I said, the only thing which you have to do is here is you have to apply the Michaelis-Menten constant, but you have to take this, that at very low substrate concentration. So here your hint of the question is low substrate concentration. Okay, so that's why the answer is option 1. Okay, sorry, the option is answer 2. Yes, Somen, your answer is absolutely right. Very good, because they have asked about the propionate utilization, so it would be double that of the acetate. Okay, yes, very good, Somen, your answer is right. Okay, so okay, Hooke's-Stinn base pairing, did anyone ever heard of this Hooke's-Stinn base pairing before? I want to know that first. Anyone has ever heard of this Hooke's-Stinn pairing before? And if yes, tell me what it is about, how it is different from, is it even different from Watson base pairing, or it is same? So where what is so different about Hooke's-Stinn pairing? Tell me, anyone. So you have to interact with me, okay? We still have the evening batch questions left, so make it fast. Evening batch part C questions we have to discuss. Evening batch part C questions were quite challenging, so in case you want to know them, you have to answer quickly. Okay, no one attended this. Okay, no problem. So see, you should not be anyways, we in biotechnical classes we have done this a lot of time regarding Hooke's-Stinn base pairing. So if you're already enrolled, you will be studying about it when we study about nucleic acids, because there are a lot of things in nucleic acids which come as questions. Okay, so accordingly, Hooks-Chin pairing, let me just show you the figure. This is what Watson-Crick base pairing is, right? We have the purine, which is a two-ring structure, and the pyrimidine, okay, in which both of them are in anti-conformation. Just now I was telling in ZDNA about the syn and anti-conformations, isn't it, of the glycosidic linkage. So we have in Watson Crick both are in anti, but in Hookstin pairing, the purine is in syn and the pyrimidine is in anti, but the purine is in syn. So this is what is a for A and T, and this is for C and G. Same thing for A and T, and this is for C and G. Now notice that for Hookstin pairing, for GC pairing, you have double bonds. I mean two bonds, two hydrogen bonding for Hookstin pairing between G and C. So this is again one more information which may come next time in question. So observation is very important. Okay, for Watson Crick pairing between AT you have two hydrogen bonds, and between G and C we have three hydrogen bonds. But because you rotate this, the glycosidic linkage means this is rotated. So when you rotate it, this anti comes in syn form. Okay, so that's why you can't form three hydrogen bond, only two hydrogen bond is possible. But anyways, here the question is, rather than observing a Watson Crick base pair, Hookstein observed a markedly different pairing scheme in which the adenine basis was flipped upside down. Now, because of this, in Watson Crick pairing, the purine N1 is connected with pyrimidine N3. Okay, and N7 is away. It is towards the, it is away from the backbone. But what happens in syn? This N7 is now rotated this side. So this is what is N7 coming here. That's why in Hookstein pairing, the N7 pairs with the N3. This is what is Hookstein pairing. Okay. So in DNA, such a flip is accomplished by a 180-degree rotation of the adenine base around the glycosidic bond. So where you have N9 to C1 dash, changing the base from an anti to syn. As in Watson-Crick base pair, the thymine base formed between two hydrogen bonds with the adenine base, one of which is identical to that proposed. So just now, as I said, the second hydrogen bond is not between N3 and N1, but rather between N3 and N7 of the flipped adenine base. So that's why the correct answer over here is option 3, because the syn purine, it is base paired with the anti pyrimidine. Because if you have both anti and anti, then it becomes a Watson Crick. Okay, if you have anti G, anti C, so that is also Watson Crick. Okay, and anti G with anti U, anyways, this is not possible because this is also in Watson Crick model only. Okay, in some case of modifications. Okay, so the last question of morning batch, yes, come on. Some inputs regarding gluconeogenesis. This is regarding the hormonal control. Yes, give me some inputs. What have you people answered for this question? How, I'm pretty sure many of you would have attended this question. This question at least. This is regarding metabolism. It is pretty simple. So many times we know, like if glucose increases, insulin increases, and if glycogen and glucose decreases, then glycogen and epinephrine increases. So while glycogen and epinephrine gives a different kind of signaling, these will be giving insulin will be giving a different one, right? So this is the question regarding the this hormonal regulation only. So yes, how many of you got it correct? How many of you attended? Are you people there? Some things tell me. So at least tell me if this is helping you. Is your concepts getting cleared with this explanation sessions? Okay, very good, all of you. Acha, option 1. Okay, so anyone else, any other option you want to go for? So have you people checked your answer keys? Anyone is having any hope or not? Okay, so no problem. I will be discussing it over here. Okay, so given below are a few statements regarding the rate of, you got 87. Oh, Graham, that's pretty close. I hope you understand what you have to do to increase your marks now, right? So um, you will have to revise more, and you have to know a lot many concepts. So if you have targeted like let's say superficially some concepts, then you have to go into more deep in depth. Or if you have targeted less number of units before, you have to target some more amount of units, so that you have maximum coverage, right? And another thing is, you have to revise in case you have studied everything but forgot in the exam and got confused. You have to revise more. All right, so see here, this is what is your let me zoom it out a little bit for you. Yeah, so this is the allosteric regulation, and this is the hormonal regulation. So since this question is about hormonal regulation, as I said, if your glucose is high, then insulin will be more. If your glucose is less, glucagon uh, will be more. Okay, so the first reaction, hexokinase glucokinase, it is inhibited by glucagon, because if glucose is less, you don't want glycolysis to proceed. In fact, this entire, whichever the regulatory enzymes are there, if glucagon is there, these enzymes will not be activated, because simple concept, if glucose is not there, you don't want glycolysis to proceed. Okay, and insulin on the other hand, if glucose is more, insulin is more, in that case you want your glucose to be utilized. So that's why you would need glycolysis to take place. So all of these regulatory enzymes, they are activating all this, all insulin is activating all these regulatory enzymes. Okay, so the question is regarding increased blood glucose, decreased gluconeogenesis. And yeah, regarding gluconeogenesis also, it is just the opposite of glycolysis, so it will be the other way around. So for example, glucagon would activate gluconeogenesis, because if glucose is less, you want the glucose to be made. Gluconeogenesis is making new molecules of glucose. Okay, so let's go one by one. The raised statement A, what it is saying, that raised blood glucose cause an increase in insulin level, which promotes glucose entry in muscle and stimulate glycogen synthetase. So what is glycogen synthetase? It builds glycogen, right? So when insulin is there, you don't want glycolysis to means you glycolysis will happen so that glucose is utilized. On the other hand, glucose can be stored also. It can be made into glycogen. When excess food is there with us, what do? Some we will utilize, some we will store for later. So that's what the body does, and that builds glycogen stores from glucose. That's why statement A is correct. But when there is a drop in blood glucose, it will cause increased glucagon and adrenaline levels. Now here, the glycogen phosphorylase. Glycogen phosphorylase is a enzyme which will break down glycogen, okay, and ultimately it will give rise to glucose molecule. So that also makes sense. A drop in glucose will cause increased glucagon, and that's why you want more glucose to be synthesized. Okay, so glycogen will be broken down. So the statement C is also correct. Statement B will be incorrect, because increased level of fructose 1,6 bisphosphate activate glycolysis, not inhibited. So they have also asked about the allosteric regulation as well, right? So phosphate, fructose 1,6 bisphosphate, isn't it? So fructose 1,6 bisphosphate, it is a product of the glycolysis. So this is what is the product, fructose 1,6 bisphosphate, you can see here. Okay, if this is more in concentration, it will give a push to the pyruvate kinase. So in another question, we saw that this is an activator of pyruvate kinase, which means it will tell the reaction to move forward, so that the flux of glycolysis keeps on moving forward. Okay, so this is actually activating it and not inhibiting it. But in case of this option D, it is saying that option B is saying increased levels of fructose 1,6 bisphosphate inhibit glycolysis. So that is why it is wrong. Okay, and statement D is also incorrect, because an increase in AMP level stimulates glycolysis and inhibits gluconeogenesis, but not the other way around. So here, correct answer is option 2, where the you have to this 1 and 3 is the correct option. Okay, clear, 1 and C is the correct option, right? All right. So mirror, mirror on the fall, I'll always get up after I fall. Yes, this time if you've got 87 marks, you shouldn't be, that shouldn't bring you down. That should be a motivation for you. It should be a reason why you have to get up. Whether I run, walk, or have to crawl, I'll set my goals and achieve them all. That should be a mantra this time. With Biotechnica, you will be able to do that. Let me remind you about our offer, which is for only today, valid only for today. That is 78% off on CSIR net coaching for Josh batch. So you have to use the freedom, you have to use the coupon code freedom, okay, for this part, right? So for you people, what I'll do is I've also posted a link. I hope you have got the link in your chat box. You've got a link over there, right? So this is what we have. The Today we are giving away the CSIR NET July 2024 question paper PDF plus answer key with detailed explanation. Okay, so you can click on in the link below. You must have got a link over there. If you click on the link, you will be able to get our freebie for today, right? Clear, everyone, right? And with the coupon code freedom, anyone wants to enroll for our Josh batch, we have a offer running only for today, 78% off on that. You can either call us our toll free number, or you can visit Biotechnica stores on our website. This is for 2024 December exam and June 2025 exam as well. Okay, now that we are done with morning batch, let's shift to evening batch. So we have our first part C question regarding the glucose molecules. Okay, so this is regarding a tree which grows at zero point 0.5 meters per day under optimal tropical conditions. Assuming the stem consists entirely of cellulose fibers, how many D-glucose residues must be added per second to reach the above growth rate? They have given the length of D-glucose in cellulose, which is about zero point 0.5 nanometer. Yes. Did anyone attend this question? First, I want to know that. Is anyone there who have attended this question? So, how do you think should be our approach? Do you need to know anything regarding carbohydrates for this actually? What do you think? Are you people there with me? Do you really need any carbohydrate um, concept for solving this question? Or is this just a aptitude question? Yes? So they have given an aptitude question over here, isn't it? Yes, absolutely right, Graham. Okay. So how will you solve this question? Tell me. Is there any formula or just like that? Anyone from evening batch over here who has given evening shift paper? No one. Yeah, I will be telling you then in that case if no one has attended this question. Okay. So, as I said, you don't have to use any of your concepts here. First of all, you have to convert the growth rate from meters per day to meters per second. Because why we will be doing that? Because they have said how many glucose residues are getting added per second. Okay, but here they have given the growth rate in meters per day. That's why we have to first convert into second. Okay, so 1 day or 24 hours, they have said that in 1 day the growth rate is 0.5 meter, isn't it? So which means that if you take in 24 hours zero point 0.5, if you take unitary method, 24 hours in zero point 0.5 means for 1 hour how much will it be? For 1 hour it will be zero point 0.5 by 24, which is around this much. Okay, now 1 hour means what? It also means 60 minutes. So in 60 minutes if you are getting this, then in 1 minute it will be this divided by 60. Okay, this divided by 60, which is this meter, this much meter. Okay, now 1 minute means it is means 60 seconds. So in 60 seconds if you are getting this much meter growth, that means in 1 second you will be getting this divided by 60. Okay, so that is this much meter. If you convert it into proper form, like not with so many points, you will get 5.77 into 10 to the power minus 6. So this is what is our growth rate, which is in per second. It's a very easy question actually. Now we can calculate the number of sugar residues added per second using the contribution of each D glucose unit. Okay, so they have already given that each, that is length of D glucose, each one of them is 0.45 nanometer, isn't it? So 0.45 nanometer per glucose unit, or nanometer you are converting into meter, because here they have given in meter. The growth rate they have given meter per second. From day to you have to convert it to per second, but to meter nanometer you have to bring it to meter. So you can say that each glucose is 4.5 into 10 to the power minus 10 meter. Now you have the growth rate per second, this much is added, and you have the glucose unit. So therefore the number of sugar residues added per second would be this length, okay, divided by the, sorry, means the rate, growth rate divided by the length. So basically the distance you are giving, right? We have the distance is equal to means you have that the how much unitary method you have to do, distance and the rate, that is distance per second, isn't it? So basically we have the uh, velocity speed, you can say, in some way, right? So speed is equal to means you have to given, they have given the distance and the time also. Not time, so basically the rate and the distance they have given. So that's why you can easily calculate it with a slight rearrangement. So 12822.22 is the answer. So this is quite close to option 2. Clear everyone, right? Okay, then this question. Yes. So a decapeptide, which is composed of this, it was dissolved in 20 millimolar Hippis buffer. So what does Hippis buffer do? It maintains the pH of a certain solution, and for this we have pH 7. Okay, this is what is your trigger, pH 7, and in that we have NaCl, Na2SO4. Anyways, that is to maintain the pH. 5 millimolar DTT, dithiotritol. So this one you must be knowing that it breaks the disulfide linkages, and EDTA again to maintain as buffer. So basically here the question is all about that the disulfide bonds are broken. So if any disulfide linkages is there, those will be broken. And which one? And Hippis means that sorry, the pH 7 means you have to calculate the charge at pH 7, because the question is about charge only. Now, the first option, if you see, the peptide forms a dimer through disulfide bond. So that is anyways not possible because dithiothiotol is a reducing agent. It will anyhow break your disulfide linkages. Okay, so option 1 is straight away rejected. Now, apart from other one, they're asking the peptide will have a net positive charge, net negative charge, or peptide is neutral. Okay, so this you have to consider at pH 7. So that's it. It's a question of calculation of charge, net charge at pH 7. So I have told you in my classes that for calculation of charges, you have to take the peptide and you have to write down the N terminal and C terminal before. Okay, so if this is the peptide, the first thing you have to do is you have to write the N terminal in the protonated form and C terminal in protonated form. And then because it is pH 7, we will be figuring out what protonation states they are in. But before that, tell me, out of all these single letter codes, these are all amino acids, which out of the amino acids will be having ionizable side chain? Tell me. Out of all this, which ones will be having ionizable side chain? Anyone knows about this part? Out of all this, which one will be having ionizable side chain? Tryptophan, glutamate. Okay, you're saying tryptophan and glutamate. So methionine, no. Phenylalanine, no. Threonine, no, because it is non-polar. Glycine, no. So Y stands for tyrosine. Tyrosine has a OH group which is ionizable. Proline, no. Cysteine, no. Again, proline, no. Then you have arginine. Okay, arginine is also ionizable, which has an NH2 plus group. And tryptophan is again no. It does have a NH group, but it is not ionizable. Okay, and we don't have glutamate here. G stands for glycine. So basically, four groups you have to consider for charge calculation. Okay, now we know that at the pK point, a group dissociates or gives away the proton. So if you take a pH below the pK point, the group will be in the protonated form. If you take a pH above the pK point, then the group will be in the deprotonated form, isn't it? So you have to know the pK points of all this. The N-terminal residue pK point is 9.6 average value. For C terminal, it will be 2.3. This is the pK point. For tyrosine, it will be 10.1. And for arginine side chain, it will be 12.5. Okay. So I'll write over here 9.6, then you have 10.1, then you have 12.5, and then you have 2.3. So these are the pK values. You have to see that the given pH is below or after the pK point. Okay, so not C, Kiruti. Cysteine C has SH, but it is not ionizable within 0 to 14 range. That is why we will not consider it. Okay, cysteine, this serine and the threonine, the cysteine residue. Oh yeah, right. Very sorry, Kiruti. That's right. Cysteine will also have. I was thinking of serine. Yeah, so cysteine, let me write it somewhere in between. Cysteine will be 8.2. That's right. Very good. So cysteine is also having 8.2, and apart from that, arginine and tyrosine will also have, right? Now the pK point, the pH is 7 if it is below or above the pK point. Okay, so 7 is below 9.6, 7 is below 9.10.1. 7 is below 8.2, 7 is also below 12.5, but 7 is after this 2.3, which means all these groups will be in the protonated form except for the carboxy terminal. Okay, so protonated form of terminal amino group is NH3 plus. Protonated form of tyrosine group is OH. Okay, protonated form of SH group is cysteine is SH group, and protonated form of arginine is NH2 plus. Okay, whereas deprotonated, the carboxyl will be deprotonated. For this, the form is CO minus. Okay, so CO minus carries a charge of -1. Okay, and NH2 plus carries a charge of +1. NH3 plus also carries charge of +1. OH carries a charge of 0 and SH also carries a charge of 0. Okay, so +1 -1 got cancelled, you're left with +1. That means the peptide has a net positive charge. Option 2 is the right option. Yes, everyone clear with this question? Do you have any doubts? You can ask me. Yes, any doubt do you have? Okay, clear, na, Graham? All right. So let's move on to the next question. Let's make it quick as we are running out of time. So this is the next question, which is based on part C. Okay, that which is based on enzyme kinetics. An enzyme has a Km of 1 millimolar. Addition of different inhibitors. This is regarding enzyme inhibition. It changes Km or Vmax given as Km or Vmax app. What is this? We know in during inhibition, the Km and Vmax changes to apparent Km and apparent Vmax. Which one of the following inhibitors will result in the lowest rate of enzyme catalyzed reaction? Okay, so we have 1, 2, 3, and 4 different options, like inhibitor which has Km app of 5 km, or inhibitor which has Vmax app of Vmax divided by 5, or in which both Vmax and Km are changing. Please note that in the first option Vmax is not changing. Okay, and in the second option Km is not changing. So if anyone knows about these different type of inhibition, in competitive inhibitor Vmax doesn't change, and in non-competitive inhibitor the Km doesn't change. Okay, but anyways, you have, that's not the question what they're asking. Which of the following will result in lowest rate of enzyme catalyzed reaction? That means they're asking which one of this will have lowest velocity. So here also you have to use the Michaelis constant. You have to basically calculate V0 by putting these revised Km and Vmax. Generally, we have the Michaelis Menten constant, Michaelis Menten equation. V0 is equal to Vmax into S divided by Km plus S. Generally, we have this, isn't it? But instead of Vmax and regular Vmax, regular Km, we will be putting these revised values, that 3 Km or Vmax by 2. And then we have to find out which is resulting in the lowest one. Okay, so for the first option, Km app is equal to 5 Km means apparent Km is 5 times that of Km, and Vmax must be unchanged, that there is no mention of it. Now what does a higher Km mean? So that solving with a, instead of going for the Michaelis Menten equation, we can directly figure out a shortcut way for that. So apparent Km is 5 times that of Km. That means here Km is increasing a lot. So if Km is increasing means we know Km is inversely related with affinity. So if Km is high, it means that the enzyme has a lower affinity to substrate. But since Vmax app is unchanged, the maximum rate can still be achieved at high substrate concentration. So that is why that this can't be the answer. Option 1 cannot be answer. This competitive inhibition, it will not have a low enzyme catalyzed rate, because anyways Vmax can be reached. But in second option, Km app is Km only, but Vmax, if you see, Vmax has reduced over here. 5 times Vmax has reduced. So here the affinity for the substrate remains the same, but the maximum achievable rate is significantly reduced. That is why this will be the only answer. Okay, here we will have lowest. If you check the third option, Km app is 3 Km, but Vmax app is just decreasing by 2. So both the affinity is also decreased because we have a higher Km, and even the maximum rate is halved. So in third option, the affinity is slightly reduced, but the maximum rate is reduced to 1/3 of it. Okay. The rate of enzyme in fourth option, rate of enzyme catalyzed reaction will be lowest for the inhibitor that causes the greatest reduction in Vmax app, because the enzyme cannot reach the full catalytic potential. Okay, so option 2 causes the greatest reduction in Vmax by a factor of 5, which will result in the lowest reaction rate. The next question was regarding the oligos. Following four oligos were mixed in equimolar concentration, heated to 95 degrees, and they were slowly annealed in a microcentrifuge tube. Which one of the following structures will predominantly be present? So, this was a tricky question because individually you have to pair them up. Okay, first of all, oligos, when they will attach with each other, you have 5 dash to 3 dash sequence given. If you want this oligo to attach with this one, you have to reverse the sequence. So that means for 2 you have to write the reverse sequence, that is C G G, then C C T, like that you have to write from the 3 dash direction. Okay, and try to match it with the first one. So like this you have to match like 2 with 1, then 3 with 1, then 4 with 1, and see that which of the following secondary structures will be predominantly present. Okay, so first of all, if we have the 1 and 2 interacting, this is the same thing which I have done. I have reversed the sequence. Okay, and then 1 and 3 are matching, then 1 and 4 are matching together. We will see that since we don't have the sequences, okay, we have a stem loop structure forming. So stem loop structure means what? Something like this. So for this nucleotide bases and these nucleotide bases, if you take one particular strand, then these should be complementary to each other. Okay, that means in the sequence only, like A and A should have been complementary, like these nucleotides should have been complementary, then only they could have formed a stem loop structure. So anyway, stem loop structures they cannot form, none of them can't form, because if you see the middle bases, they can't form complementary base pair. So option 2 is not possible for them. Okay, that can occur in the single strand or RNA if sequences of two regions of the same strand are complementary to each other. This is not observed in any of the oligos, and so option 2 is ruled out. And left-handed ZDNA are mostly found, I have told you, in alternating purine pyrimidine sequences. So they have also said that two separate Z forms of double-stranded DNA will be formed, but none of these would form Z form also, because Z form generally has alternating CG, but none of these sequences show such kind of sequence. So the only two options possible is two separate strand of double-stranded DNA structure, and or else you have a four-stranded holiday junction. Now to form a double-stranded DNA with one, at least two, three, or four, one of them should completely match, or at least like maximum it should match to be able to form a double-stranded structure. Okay, but if you match 1 and 2 or 1 and 3 and 1 and 4, okay, complementary binding, you will see that none of them have like lot of complementarity, complete complementary. Rather, they have only partial complementarity. Since we don't have these sequences here, option 3 is ruled out, that is ZDNA. Checking for complementary binding between first and other sequences, we see that they have only one partial complementarity, which means they are likely to form a double stranded DNA. So, thus, option 1 can also be ruled out. Okay, so none of them have complete complementarity, that's why this is also ruled out. On the other hand, these sequences are likely to take up a holiday junction structure, which consists of four strands. So how does holiday junction look? Something like this. Okay, so as you can see that there are four strands. So this one strand, partly let this be first sequence, second sequence, third sequence, fourth sequence. So first is partly having complementarity with second strand, but not entire of it. Okay, so the rest of the second strand is having complementarity with the third strand, but only half of it. Okay, and the other half of one is having complementarity with half of the fourth strand. So that is how a holiday junction is formed. So if you check these like 1 and 2 or 1 and 3, 1 and 4, you will see that one is having half of complementary binding. Okay, because 1 and 2, for example, it is having in the first half, and if you check 1 and 3, they are having more or less, 1 and 4, if you check, so they are having more or less complementary binding in the last half. Okay, so that's what I said. So 1 and 2, you can see half part, first half they are having binding, and the next half is having bonding with 4. So these sequences are likely to take up a holiday junction structure which consists of 4 strands, each participating in 4 anti-parallel base paired arms. Thus, here first sequence can possibly partially pair up with fourth sequence and partially with the other sequence. Okay, so option 4 is the best answer, that they would form a holiday junction. Okay, I hope you people are getting this part. Now, the next question was very easy. It was based on beta oxidation metabolism. They have given a ordering question. They have given some critical steps in the reaction, and you have to arrange them in ascending order. As I have always said, for ordering questions, you should pay attention to what they are asking, either ascending or descending. Okay, so that means you have to arrange in a way that the earliest steps should be first and the last steps should be at the back. Okay, so out of that we know that before everything needs to take place, first we need to have the fatty acids transfer into the mitochondria. So for this, the fatty acid must react with carnitine. Carnitine is what you have. Okay, so we have to actually start with the lipase, that means breaking off the fatty acid. Okay, so fatty acids, we know they are broken down from triacid glycerols, glycerol backbone to that, where 3 fatty acids are there. So each of these fatty acids need to be first broken down. Okay, then these individual fatty acids will be transported to mitochondria, and then they will be picked up by the through the carnitine shuttle they will be transferred. That's why the next has to be reaction of fatty acid with the carnitine. Okay, so after C we need to have A, right? So oh yeah, before the fatty acid they have to be conjugating with CoA. So once we have the fatty acid released from triacyl glycerol, the individual fatty acids need to be associated with acetyl, means they have to be conjugated with CoSH enzyme so that they can form fatty acid CoA. Then only they can join with carnitine. So first we have C, then we have D, and then we have A. Okay, so that's the option which we see in option 1. And the last two steps that you see, that is hydration and then you have thiolysis, these two are part of the beta oxidation. So as I said, the triacyl glycerol, from there free fatty acids are removed by lipase. So free fatty acids, they will attach with CoA to form a fatty acyl CoA, and then the mitochondria, this was happening in the cytosol. Now the fatty acyl CoA cannot be transported just like that, so it has to be transported with carnitine, forming an acyl carnitine complex, which can be translocated through this acyl carnitine translocase. That way only it can cross the inner mitochondrial matrix. Anyways, a membrane. Anyways, the inner mitochondrial membrane is impermeable, so that's why they need to cross like that. Then once it enters the mitochondria, it will be completely oxidized. So step by step, it will be broken: oxidation, hydration, oxidation once again, and then thiolysis. So that is why option 1 is the right answer. Okay. And the last question of evening was regarding an electrostatic potential map of an 18 kilodalton protein. So we have in this one, they are asking, they have shown the protein from two different angles. So this is the front view and this is the back view probably. Okay, so we can see most of this are blue in color, right? So what does blue color denote? Blue color denotes positively charged residues, whereas red color denotes negative charge, which means that this protein is majorly built of positively charged residues on the surface, right? So positive charge residues, obviously they will interact with negatively charged residues. Now this was little bit easy, I will say. Negative charge residues, we know our nucleic acids have negative backbone, isn't it? The phosphate backbone in DNA RNA, that those are negative in charge. So that's why the maximum interaction with this protein is possible with nucleic acids. See, cellulose, it has it has polar groups, polar residues, but they are not really charged at pH 7. So they will not interact so well with the charged protein, means a protein with charged residues on the surface. So only cellulose, definitely not. And in DNA cellulose or DNA RNA will be a better choice because both have a negative phosphate backbone. Okay. Fatty acids, definitely not, because they are hydrophobic in nature, and we are talking of polar residues which are positive in charge. So that's why The correct option here is answer 2. Okay, so that's all from my end. Tomorrow we would be, let me remind you regarding tomorrow's session. Tomorrow unit 2 and unit 3 both will be discussed. So from 7 you have a live session, 7 to 8:30 we have unit 2 discussion. Both morning and evening batches, all part B part C questions will be discussed, and with their detailed explanation as you got here. Okay, the the thing what you get is, with these sessions, the analysis of a particular question paper not only helps you gain knowledge, okay, but also it is kind of a cross preparation. You are getting so many things to know all at once. Okay, so I expect your active participation tomorrow. The coupon code freedom, let me remind you, use the coupon code freedom if you want to enroll. This offer is valid only for today. I have also posted the link for your freebie, that is downloading the question paper of explanation. You can click on that link and you can download our free freebie for today. Okay, that's all from my end. Thank you everyone for joining in. Tomorrow, 7 o'clock, Unit 2 and 8:30, Unit 3. Thank you.